Hi, everybody. Let's take a look and see how we can use processing to create a blurry image. It's a fun little algorithm to play around with here. For this, I'm going to be using a picture of my dog, Lola, here. Let me get some information about Lola. Inspector, and I've got 800 by 976 pixels. I'm going to need to remember that. 800 by 976 pixels. This is the picture I'm going to be working on in my project. That's the picture I'm going to blur. So let me go ahead and create a new project in processing. So it starts out as a sketch, and we are in Python mode, so we'll remember that. And let me just go ahead and save this. I'll save this as uh, blurry, image blurry. I've been using image for everything, so image blurry, I'll call that. And I'm going to paste in the code from that basic image processing file that we did, that we looked at. We're loading up an image here, with specifying the size, displaying that image, and then going through and making some changes to the colors of the pixels in there, and then saving it as a new file down there. And we're going to do something very similar with this image of Lola. We're going to make some minor changes, however, to what's going on here. So first of all, let's double check. Let's take a look in that processing folder, because if I'm going to have a, I've saved that there as image blurry, right? And so if I'm going to be working with an image, let me bring that over here. If I'm going to be working with an image in that project, I need to make sure that that image is available to the project. So I'm going to drag that picture of Lola over there. And again, 800 by 976. So let me go ahead and close that. The size that I'm going to be working with then for Lola is 800 by 976. And this is going to be Lola.png. And then that, remember, that image is just going to display that on the screen. I'm going to comment out. I'll use triple single quotes here to comment out the rest of this code, because I just want to run this and see if I'm actually getting that image displayed. Testing as we go here. And oh, there's my pup. Good looking pup. And that image doesn't look terribly blurry. It looks like it's pretty much in focus. So I'm looking at the whiskers in particular here to see. So I'll be able to take a look and see. I can distinguish individual strands of hair up there. So that's pretty nice. It does look a little bit blurry in the background, but she looks reasonably sharp here. So that looks like that's working okay. So let me take a look and see what strategy I'm going to use for analyzing this picture and blurring it out a little bit. So first of all, I guess I don't want to mess up my original image. So in addition to setting up this image of Lola here, I'm going to set up an image 2, which is going to just be a blank image, right? So instead of loading an image, I'm going to use the create image command. And for that create image, you have to tell it the size of the image you want to create. So that's also going to be 800 by 976. And this is going to be an RGB color image. I'm specifying that I'm using those colors there as opposed to some other coloring schemes. So I think we're all set there. I'm going to be working my way through image there and creating a new image based on what I find in the old image. And I'm going to use the same strategy of going through the entire range of the picture there. But here's what I'm going to do. I'm going to make a little modification here. Rather than just looking at each individual pixel, I suppose I am going to look at each individual pixel, but as I look at each individual pixel, as I look at this RGB value here, I'm going to be looking at the pixels around it as well. And one of the things that gives a picture a sharp definition or being in focus is big differences in the colors between one pixel and another. And if we were to smooth out those differences, make those colors closer to each other, then what you end up doing is blurring or decreasing those distinctions, decreasing those edges. So what I'm going to do is I am going to go through for every row and for every column. I'm going to go through, and for each pixel that I'm looking at, I'm going to take the average color of all the reds that are around this, and including this one, I suppose I'll include that one there. I'm going to take the average red color for all of these. And this red might be brighter or darker, and this will be brighter or darker, but I'm going to average those, and I will reset this color for this pixel based on the average of the surrounding reds there. And then I'll do the same thing, average of the greens and average of the blues. And in the end, this pixel right here is going to have a color that's a little bit different from what it was before. It's going to be an average of some of those surrounding colors. And that's going to have the effect of smoothing out the colors rather than having those sharp edges. So how does that work? What am I going to do in my loop here? Well, let me, I'm going to just comment this out for the moment. I'll get rid of that because I'm not going to just be getting those individual column and rows. I need to get the pixels all around those columns and rows. So let me actually set up a new loop here. I've already got a loop that's going through for every row and for every column and getting those pixels. So I need to go, I guess if I'm at column and row, I'm going to set up a smaller loop that says for y in range 1 less than my current row to 1 greater than my current row. And we say row plus 2 because, of course, the range stops 1 before that. It's non-inclusive for that. So this is going to check the rows above and below my current row. And then I'm also going to say for x in range column minus 1 and column plus 2. And again, that's going to be going through and checking. Here's my row. Here's if this is row 3 right here, then this is going to check this new loop in here is going to check from 2 all the way up to 4. And if my column is 7 here, I'm going to check all the way from 6 up to 8 for my columns. So every time I check a pixel, I'm actually going to be zipping around each of those 9 pixels there, getting the color that's there. So let's get that color. I'll say C for color. C is equal to the image.get of the pixel that is at each one of those individual little locations, those 9 locations. Those are indicated by X and Y. I'm going to get those colors, and I'm going to break them up into individual reds. I guess I need to I'm going to get a red color for that, and I need to add it to all the other reds because I said I was going to average, right? So maybe I'll set up a red sum that starts out as 0, and a green sum that starts out as 0, and a blue sum that starts out as 0. And then every time as I'm ripping around through those 9 pixels, I'll take red sum and add to it whatever the red color is of my current pixel, that red color there. And I'll do the same thing with the green sum. So I'll be adding up all the greens for those 9 pixels, and the blue sum. So I'll be adding up all those. So that's going to be getting me some larger value. Obviously, I'm adding those all together. I need to divide then by the number of pixels. So my new red color that was left over from before, my new red color is going to be whatever the red sum was divided by the total number of pixels. And that was 9 altogether. Same thing down here for the green. I'll take the green sum and divide it by 9 to get an average green color there. And then a blue sum divided by 9. So that's going to get me those averages. And then I will just set those in my, I'm not going to change image. I want to keep image the same, but I'll set image 2 to that column, row, whatever color I've got from that new red, new green, and new blue, those average colors there. And then what I'm going to do is I'm going to display that image on the screen. I'm not displaying the original image. I'm displaying image 2. And then I'll also save that as altered image. Maybe I'll call that blurry Lola instead of whatever I had there before, altered image. Let's run this and see what happens. It'll be very interesting to see how this works. So it's going to take a little bit longer than it did before, maybe because it has to zip around and do 9 pixels for every 1 pixel that I'm going to get. And there you can see, there's the new image. Does it look a little more blurry to you? I can still see some individual strands of hair there, but let me open up. I'm going to go ahead and open up the original image of Lola there and see if we can compare those two right next to each other. Image blurry, there it is, and here's the original Lola. So I'll expand that a little bit, and you can see there, yeah, looking at the background, I'm looking at her hair there. It does look a little bit blurrier, doesn't it? It may be because the screen has expanded a little bit. If I were to expand this, I wonder if it would look. I still see like it feels to me like it's a little bit blurrier than it was before. But you know how we can be sure is we can do we can do this. Oh, this will be fun. Think about this for a second now. If this was going, I'll get rid of this part here because I don't need that. If this was going through and getting one row before and one row after, and one column before and one column after, even blurrier would be if I were to include two rows before and two rows after. Two rows before, two columns before, and two columns afterwards. I wouldn't be dividing by 9. Now I'm going to have a total of, let's see if I have an extra, if I've got an extra row on either side there. So this is 1, 2 below. So this is going to be a total now of 1, 2, 3, 4, 5. 5 by 5. I'm going to be doing 25 pixels here. And that means to get the average, I'm going to have to divide by 25. Interesting. Let's do that, and let's see how this changes everything. I'm going to go ahead and run that. And I imagine it's going to take even longer for this to happen because now I have to check for every pixel in my original image. I have to do 25 checks just to calculate that new average. And now it really is starting to look quite a bit more blurry, isn't it? For me, if I bring this up here, definitely blurring out quite a bit there. Even if I expand this here, you can start to see that, yeah, that hair is becoming less distinct there. These are about the same size there. The mountains are losing some of their definition. The succulents back here are starting to blur out a little bit. So obviously we can vary the amount of blur just by changing the amount of averaging that we're doing. It obviously does take time to do all that. It may not surprise you to learn that there are multiple algorithms, different strategies that people can use for creating blurs. This is just one relatively simple one. Last thing I'll mention, if you're interested in making this a little bit less hacky, one of the things you can do is, of course, you can set a scale at the beginning of your program and say, well, how many pixels do I want to take into account? How far do I want to go? If our scale is set to 2, for instance, I could say down here, instead of doing row minus 2, I could say row minus scale and row plus scale plus 1. Same thing here. This is a way of just kind of combining all those calculations that we're doing and making them all a function of a single variable. You might be interested to think about, well, how does that scale there? 2 represents how many pixels? How do I get 25 from that? I think that was, well, I had the pixel itself and then 2 before and 2 after. So if I took 2 times scale plus 1, 2 times scale, and then add 1 to that, that's going to get me 5. And then what I need to do is square that value. So can I do a 0. How about if I do that? That'll get the 5, square it, and then I'll divide that out. And we'll see if that does exactly what we're thinking about doing. The numbers before worked fine, but they are what some people call magic numbers. And so this way is a nice way, if you include that scale in there, that's a nice way of making sure that all those numbers are not magic. They're all given as a function of this scale process here. So I'm expecting this blurry image that's going to show up. It looks exactly like that. But now here's the fun thing. I can actually say, well, what if I wanted to go up to 5? 5 is going to be out of control, but now I just have to change that one number. And 5 is obviously going to take a very long time to go through because now I'm doing, what, 5 before and 5 after? That's 11 by 11. That's 121 calculations for every single pixel on there. And we've already got, what, close to 100,000 pixels that we're working through. So I expect that this would be taking a little bit more time than would be comfortable. But it's nice to know that the computer can do this kind of thing. And I'm probably just going to keep talking to you for another moment or two before I turn this off because I want to see what happens. I'd like you to see what happens here as a result of this. I don't know if you can hear, but my fans are spinning up. I've got, oh, it's a very blurry picture of Lola. That's lovely. That's just lovely. Anyway, hope that helps.